In the values of a and b that make f continuous everywhere. So this f is given by these three pieces. The first piece when x is less than 2. So everywhere means negative infinity through positive infinity. If we look at the domain, this function is given by this rational function when x is less than 2. I don't know, somewhere to here. So on the left of 2, not including 2, we have this rational function. In between 2 and 3, 2 included, 2 and 3, somewhere 3, let's say here, 2 included, but 3 is not. Here 2 is not included. In this domain, this function is given by a polynomial. And for x bigger than or equal to 3, 3 and bigger, on this domain, we have another polynomial. And we know that polynomials are continuous everywhere. So this piece is continuous everywhere. Everywhere means in its domain. And this is also continuous in its domain. And this rational function is also continuous in its domain. What is the domain of this rational function? All reals except 2. And in fact, this function is defined for x less than 2. So 2 is not even in the domain. So this is also continuous. So each piece is continuous. So the issue here is at the endpoints. What happens at 2 and 3? If this function is continuous at 2 and 3, then this will be continuous everywhere. So the issue here, there are two places, are at x equals 2 and 3. And for a function to be continuous, we need to satisfy three cases. At least the limit at that values, x values, should exist. Limit exist means left hand limit should be equal to right hand limit. So I'm going to apply that. So for f, for the limit of f at 2 exist means limit of the function when x approaches to 2 from left should be equal to limit of the function when x approaches to 2 from right. This should be the same so that limit exists, and we have more conditions to satisfy, but this is necessary condition. And same thing at 3. So at 2, for left hand limit, I'm in the left, so that's the left part, and this is the right part. So for 2, this will be the left and this will be the right. So I'm going to find the limits there. Okay, so at 2, limit of the function when x approaches to 2 from left is limit x approaches to 2 from left of this function, this piece, x squared minus 4 over x minus 2. Now this negative is nothing, just for the limit. If we directly plug in x equals 2 squared 4 minus 4, 0 over 0. So we need to simplify before we plug in. Simplify means factor the top. This is a difference of 2 squares, so we get x plus 2, x minus 2. On the bottom, we already have x minus 2. Cancel. Now plug in 2. This negative is just for the direction. 2 plus 2, 4. Now similarly, we want to find the right hand limit when x approaches to 2 from right side. For right side, so we're going to use this polynomial. So limit x going to 2 from right side of ax squared minus bx plus 3. Oh, this is a polynomial, so all we have to do is simply plug in 2 for x. So 2 squared 4a minus b times 2, 2b plus 3. So this is left hand limit at 2 and this is right hand limit at 2. For the function to be continuous at 2, left hand limit should equal right hand limit. Then this right hand limit, let me write this first. 4a minus 2b plus 3 should equal 4. From this we cannot determine a and b because only one equation, but let me subtract 3 from both sides and I get a nice equation, 4a minus 2b equals 1. For future reference I'm going to write 1. Now we do the same type of work at 3. So when we are considering at 3, okay, for 3 this function will be left and this one will be right. So this is left and the function is right. Okay, so let me do that. At 3, limit of f when x approaches to 3 from left is limit x approaches 3 from left. So this ax squared minus bx plus 3. This is a polynomial, so all we have to do is just plug in x equals 3. 3 squared 9a minus 3b plus 3. Okay, now let me find a right hand limit when x approaches to 3. So the very last function, 2x minus a plus b. This is a polynomial, so all we have to do is simply plug in x equals 3. So 2 times 3 is 6 minus a plus b. And for the function to be continuous everywhere, it has to be continuous at 3. That means this should be same. Okay, that means 9a minus 3b plus 3 is 6 minus a plus b. Let me write a nice function. So I want to bring a to the left side, so add a, subtract b and subtract 3 to move number over. That gives 9a plus a, 10a minus 3b minus b minus 4b equals 3. So we cannot find a and b because we have only one equation and two unknowns, so I can call this equation 2. Now we have equation 1 on variables a and b, and same thing here. Now we got a system of linear equations and we know how to solve using college algebra. So we can use method of elimination or method of substitution or graphing. So let me put them together. This is equation 2. I'm going to write equation 1 together. 4a minus 2b equals 1. Looking at this 4b, 2b, I want to use the method of elimination. I want to multiply equation 2 by negative 2 so that this becomes negative minus negative positive 4b. And when I add, negative 4b plus 4b will be 0. So I can eliminate variable b, then I can determine the value of a. So I'm going to multiply by negative 2, then add these two equations. Okay, so I didn't do anything for equation 2, so this is 10a minus 4b equals 3, multiplying by negative 2, negative 8a plus 4b equals negative 2. So we are adding, that means 10a minus 8a, 2a cancel, that was the purpose, and that equals 1. So this implies a equals 1/2. So we found the value of a, and the question is to find the values of a and b. Now we can plug in a to 1 or 2. So plug a equals 1/2 into which one is easier, maybe 1 without, into equation 1. You can plug in into 2. 4a, so 4 times a minus 2b equals 1. Okay, 2 goes 4 twice, or 4 times 1/2 is 2, minus 2b equals 1. 1 subtract 2 from both sides, minus 1, divide by negative 2, so b is 1/2. So thus when a is 1/2 and b is 1/2, this function is continuous everywhere. Continuous means when we graph the left hand side, this part and this middle one, they come to the same place, and the third also come to the same place. Okay, we'll have a continuous graph. Okay, so the answers are A is 1/2, B 1/2. Final.